Okay, first we're going to look at the second derivative test. All right, we already learned how to use the first derivative to find the relative maximum and minimum, but now we need to use the second derivative test. All right, this is what we do. The very first thing, we want to find our critical numbers. Remember, our critical numbers will be 3x squared minus 6x, that's the derivative. The derivative of a constant is 0. Set that equal to 0. We factor out a 3x. So our critical points are 0 and 2. Based off here, I have to save time, a little bit of time and more so space. These are our critical points. Okay, now this is what we have to do. Now we need to come up and find the second derivative. The second derivative here would be 6x minus 6. Okay, and now what we do is evaluate our critical points into our second derivative. Okay, if it's less than 0, we have a relative maximum, but if it's greater than 0, we have a relative minimum. Okay, so now let's go. F double prime of 0 is equal to 6 times 0 minus 6. That answer is negative 6. 6 times 0 minus 6, that's negative 6. That is less than 0, so we have a relative max at 0, and then you can plug 0 back in to the original 0, 0, 4. Okay, now let's plug in our other critical point. 6 times 2 minus 6. 6 times 2 is 12 minus 6, which is 6, which is greater than 0. So we have a relative minimum. Alright, it's great. The answer is greater than 0, so we have a relative minimum at 2. And once again, plug 2 back into the original. 2 cubed is 8. 8 minus 3 times 2 squared, that's negative 4 plus 4. So we have a relative minimum at 2, 0. Okay? Now, what you can do is, you can also use the first derivative test if you ever want to just check your answer, but this is the second derivative test for relative maximum and minimum. We did not have to set up the number line to see if it was increasing or decreasing like we did the last time, all right? Because we're using a different test. It's a little bit faster too.